Hey everyone, hey YouTube. I decided to come back to the peak of the week. As you remember, there it might be a short 5-minute video or it might be pretty long depending on the complexity of the problem. So today I decided to just refresh how to prove or derive quadratic formula. As you remember, this is a specific way how you can solve quadratic equation in the form x squared plus bx plus c equals to 0. So that's everyone welcome, especially students of GCSE and A-level maths. There is also applicable to IB students if you want to know how it can be done. And also for those who still struggling with completing the square, because definitely we're going to use that for now. Alright, so let's get to the point. Alright, so in this assignment, by completing square, we need to show that x squared plus bx plus c equals 0, basically quadratic equation, can be solved to give the following expression for x, basically solution for x. So x can be found using this formula. That what is known quadratic formula, alright? So how to derive that? I'm gonna use completing square as according to the assignment. Okay, so that's why the first step is to factorize a from this expression. All right, so I just take the part of that and factorize a from there only. So that's why I'll get x squared plus b over ax. In here, I'll still have plus c equals to 0. Now, I want to get the completed square. So what it means, completed square, because we have the sum, I'll just set up in this form. So x plus, let's say some y, okay, squared. Obviously, I want to get this, and that's why in expanded form, I should have this as the following. So x squared plus 2xy plus y squared. All right, so right now I have only two terms, so that's why I'm thinking about y squared, and that's why I need to know what y stands for. So that's why I just rewrite a. I have the first term x squared according to the general formula. Next, I need to have double product of the first binomial term, so this case is x, so that's going to be 2 times x, okay, and y, right? But instead of y, what I need to have in order to come back to the original term, which is b over ax. So I need to write obviously b over a, but now I have double x b over a, while I have just the single one, no coefficient 2. So that's why I immediately need to divide by 2. So why I use this structure? Because right now I can compare that 2x is 2x here, and b over a is what y represent, all right? So this is b over 2a. So that means I need to add y squared, which is b over 2a squared, b over 2a, everything squared, and I need immediately to subtract this because I didn't have anything, right? I had only two terms, but I need y squared, which is b over 2a squared. So that's why I immediately subtract this, okay? I subtract this and I just simply write b over 2a squared, okay? And just closing brackets. So right now I have this completely in equivalent form, so right there, okay? On top of that, I need to add c and equate to 0. So maybe it's just a bit messy, but I'll rewrite this real quick. So x squared plus 2xb over 2a, this is y, what we found. Then I add, okay, now I just want to expand that. B squared over, as you remember, if you have the index form, you have the power in brackets, so this power will be distributed to every part of the fraction, to the numerator and to their denominator, which will generate 4a squared, okay? Now I also subtract this same term, okay? Closing brackets, and on top of that plus c equals to 0. All right, so everything is done. So the next step is to actually complete the square that we're going to, okay? So that three terms will give us completing the square. So I can write that it's going to be a x plus y according to this formula, right? X plus y squared. So that's why x plus b over 2a, that's what y stays for, and squared, okay? Well done. But because it's only up to this stage, so actually I need to times my a as the common factor by minus b squared over 4a squared. So if I times that, I'll get a times b squared over 4a squared and plus c, all right? So right now what I'm gonna do, I just squeeze it up, all right? And I just want to say that we're already almost done. So what I need to do, I need to transfer this part to the right side and leave left part as it is. So I will write a times x plus b over 2a, everything squared. On the right side, if I go to the common denominator, 4a squared will just go straightly here, okay? So that means I'll get 4a squared c. But if I transfer every single term here and here, I'll change the sign. So that's why I'll get ab squared. Sorry, my bad. It's better to cancel a and a squared first. So that's why just only 4a will go there. So that's why it's going to be just b squared minus 4ac. One more time. 4a goes here, okay? Just let me erase so that you got it. Here we go. So because we cancel a and a squared and only 4a goes here, but we also need to change the sign because we transfer it to the other side, okay, of the equation. So that's why b squared becomes positive while it was negative before, and plus c becomes negative c, and c gets 4a, okay? Hope you got it. So that's about how to make the common denominator. So over 4a, all right? Now it's done. I just want to express, because our goal is to express x is inside those brackets, so that's why I'll get x plus b over 2a, everything squared. What I'm going to do right now, both parts I'm going to divide by a, okay? A will be cancelled here, and it will appear on the right side in the bottom part because I'm dividing. So it's going to be 4a squared, okay? So this is done up to this stage. And the last part is to take the square root of both sides. When you're taking the square root, for example, like this, equals 4, when you're taking square root, of course you'll get two values, plus minus square root of 4, which is 2, okay? But you're satisfied with both values, both negatives and positives. So that's the same story. If I take the square root of both parts, I'll get this. b over 2a equals 2. I'll just immediately write plus minus. Then I'm going to take the square root of the top and of the bottom, right? So I'll get square root of, one more time, square root of b squared minus 4ac, and over 4a squared will generate just 2a in the bottom part. And finally, what I'm going to do, I'm just going to transfer b over 2a term to the right side. So I'll get x equals 2. Because denominator are the same, I just can put the common denominator 2a. And because b transferred to the outside, it will be in the numerator, it will get also negative sign. Okay, plus minus square root of b squared minus 4ac. And we've got the target formula right now. So sometimes instead of writing b squared minus 4ac, we use discriminant, which is b squared minus 4ac, and it's very well-known expression because it will allow us to analyze for existence of the roots or solutions. All right, so that was short. That was pretty short, it seems to me. That was complete derivation in general forms, in basically in using algebraic methods. Hope you got it. If not, just try to rewatch. And actually, if you can't deal with just general letters, like with algebraic fractions, you can deal with numbers with no doubt. So subscribe if you're new here. Also visit my dance channel. So Daniel Dallas Dance. You can search me on YouTube as well. And see you next time.